Thank you all for joining us today for the first in a series of 4 webinars by OpenTopography. This is our spring webinar series. We've done similar ones in past years, but this is a first one since 2023. Um, and we'll talk more about the schedule and sort of the overview here in a second. But I did want to note that this is a webinar Zoom, which is a little bit different than a standard Zoom meeting. So you're all muted by default. And I'll have a slide about sort of logistics of how we'll run Q&A and things like that in a second. But since somebody asked, just want to make sure that was clear to everybody. If you don't see a mute button, that's because you're automatically muted. Um, okay, yeah. So today, my name's Chris Crosby. I'll be the primary presenter, and I'll be joined by Matt Beckley. And then Chelsea Scott is also here from the Open Topography team. And they'll be available to answer questions and deal with the chat as we go along. Our goal today is to spend about 45 minutes talking to you, maybe a little bit less than that, depending on exactly how things go. And then we will answer the Q&A and other topics that come up. Oops. There we go. So just a reminder, this is the Spring 2025 webinar series. We're here on March 5th. We will meet every Wednesday at 1 p.m. Eastern, 11 p.m. Mountain Time for the next 4 weeks. You all registered and should have gotten a link sent to you, which obviously you did since you're here. But the reminder is that Zoom details work for the next 4 meetings. So you should just use that same link to connect for the future webinars. We will be recording these and we will post them to our YouTube channel. It takes a little while for Zoom to generate the file, and then we'll do some editing and cleanup. But these will all end up on YouTube, so feel free to share them with your colleagues, or if you just can't make one, you can come back and catch the recording at a later date. So logistics, as I said, this is a Zoom webinar, so basically only the presenters and moderators are set up to speak at default. So that's myself, Chelsea, and Matt. And there's a Q&A option. It's in the Zoom toolbar. So if you have a specific question, please post your question in the Q&A. Matt and Chelsea will chime in, and as we go, potentially answer questions if they're simple or if there's a link that people are interested in, those kinds of things. We'll share those as we go. Questions that maybe require a longer answer, a little bit more discussion, we may hold to the end of the presentation so that we can kind of deal with them at the end. And again, as I said on the previous slide, all 4 webinars use the same Zoom link. People were confused about this when we did the last webinar series, so I want to make sure that's clear. We will try to send an email every week, however, to remind you all about this, but the Zoom should not change, so you can set an event on your calendar and have it recur. Okay, so today, let me go back here for just a second and talk about the arc of the program for the next 4 weeks. So the goal here is this is meant to be a relatively introductory series of webinars. And the goal is to kind of talk about open topography as a resource. And that's what we'll mostly do today. So it's sort of like an overview of what open topography is, a little bit of its history, some functionality and capabilities at a high level, and try to make you aware of some other resources you may or may not be aware of. Because there's a lot of people who use open topography in one specific way, but may not appreciate there's other things available to them. And as we've been doing this now for over 15 years, the site has gotten more feature filled and more complex. So the goal here is to kind of make people aware of all these things, and hopefully you'll be like, oh, I didn't know I could do that. That's cool. And so that's like today. And then next Wednesday, we're going to focus on kind of point cloud data. So we're going to talk about how you produce point cloud data, primarily focused on LiDAR as a technology. And then we're going to talk about open topography tools for accessing, processing, visualizing, downloading, et cetera, point cloud data. Then on the 19th, we'll do a similar thing, but with a focus on digital elevation models, so sort of raster representations of topography. If you're somebody who does a lot of GIS, this is probably most familiar to you with these kind of data sets, but we'll go through terminology and basics of digital elevation models, and then we'll talk about how to use open topography to produce your own DEMs or to download DEMs and some other capabilities for sort of bulk access and things like that. And then in the last week, we're going to focus specifically on topographic differencing. So this has been an activity that's been a focus of open topography for the past several years. Chelsea will lead that webinar with Cassie, who's a postdoc who works with us. And they will talk specifically about how to use the tools inside of open topography to intercompare data sets and produce maps of change. So that's the plan for the next couple of weeks. So starting with like what is open topography? So, open topography's goal is to democratize online access to topographic data in general, but really our focus has historically been on high resolution topography. So these are typically data sets collected with LiDAR, although oftentimes also now people are using photogrammetry to do this. When we say high resolution, we typically mean a pixel resolution of roughly a meter or better, although this is not a firm definition. Some people might say 2 or 3 meter pixels is still high resolution data. Um, but this is kind of the bread and butter of open topography. And we're really interested in providing access as well as tools to allow users to interact with these kinds of data, whether it comes from a laser scanner, whether it comes from a photogrammetric workflow, whether it comes from a satellite like a radar or a laser altimeter or other types of tools that collect these kinds of data. And we'll talk more about the sort of nuances of these sensors and data types and things in future weeks. But this is really what OpenTopography is all about, and it has been motivated by since we started doing this work. What is OpenTopography? is a question that actually gets asked somewhat regularly. It's a collaboration that's primarily funded by the U.S. National Science Foundation through the Earth Sciences Directorate. We started doing this in 2009, and it's a collaboration between three institutions. So the San Diego Supercomputer Center, which is at the University of California in San Diego, is kind of the technology arm. A lot of the compute infrastructure, software engineering, et cetera, happens at the San Diego Supercomputer Center. Matt and I work at the EarthScope Consortium, which is a nonprofit organization. Matt and I are both based in Colorado, although EarthScope has people all over the country. And EarthScope primarily supports National Science Foundation as well as USGS, NASA, NOAA funded geoscience research. So we're a kind of data and infrastructure facilitator for the research community primarily. And then the third partner is Arizona State University, where Chelsea is based. Uh, and that's so this is the team here in these pictures. So Vishu on the left is the principal investigator of the project at the San Diego Supercomputer Center. Myself, Ramon and Chelsea are at Arizona State. And then in the lower row, Min is a software engineer at SDSC. Matt at EarthScope is a data engineer. Emily does education outreach and engagement kind of work with us. She's an EarthScope employee as well. And then Cassie is a postdoc at ASU currently. So it's a small team, and none of the people shown here work full time on Open Topography. Everybody else has other jobs as well, other projects they're involved in. So it's a relatively small but agile team, and we've had the fortune of all working together on this for quite a while now. So the team's pretty tight, and we do everything remotely. There is no sort of office for Open Topography, so to speak. So what we primarily do is topographic data hosting and distribution. So this is probably how you found Open Topography in the first place, is you used it to get data for some spot you were working on. And the kind of the magic of Open Topography, the thing that has made it a little bit different than many other kind of geospatial data clearinghouse type environments, is this ability to build processing workflows in a web browser. So to produce derivatives from relatively raw, relatively large volume topographic data sets and spit out the thing you actually need to do your research or your project. So that could be making a custom digital elevation model. It could be producing, contours of topography. It could be just looking at the data in a quick and easy way. And so we've really focused on that piece since the beginning. And I think that's what sort of sets Open Topography apart. But the portal is not the only thing in Open Topography, and we'll talk more about this in future. Matt will, in the coming weeks, will show you some other things, but there are things like APIs to access data programmatically. We publish data in cloud native formats that are available for bulk and kind of programmatic access. We've done a fair amount of development of Jupyter notebooks and open source code that are available to you. And then education and training has always been a big part of what we do. We've taught something like 45 different short courses and workshops and webinars over the years on these data types and how to use them in various ways. So we have a fair amount of experience in this, and this is something that also underpins our work and is part of why we're funded by the National Science Foundation, is kind of the workforce development component. So we're talking about topographic data. We're talking about these kinds of products. So this is Indianapolis Motor Speedway as an example. On the left is a LiDAR point cloud data set. So this is the raw laser bounces, the kind of XYZ positions of the Earth's surface underneath the place where the plane flew. In this case, it's coded, it's colorized by laser intensity. So we'll talk more about this next week. That's a raw data product, and for some people, that's very challenging to deal with. Increasingly, there's good support for these kinds of data types in your common geospatial software packages, but these data sets are very large uh, and very rich, but also kind of challenging. So what a lot of people end up doing is looking at these data in a raster representation. So a digital elevation model is the general term for these. This is where each pixel has an elevation value associated with it and a size. So it's a 1 meter digital elevation model, or it's a 30-meter digital elevation model. Uh, and then from those digital elevation models, we can produce derivatives. So something like this image is a hillshade. It's an artificially illuminated with a sun angle imposed upon the topography to generate shadows and light on the landscape. Very common way to look at these data, but you can also look at them as slope or aspect or roughness or any of these other derivatives of topography. And then the kind of more traditional way, and still common in some sectors, particularly like in the engineering world, in particular, things like contour lines. You know, if you're used to looking at a 1 to 24,000 USGS topo map, it was all contour line based. And so that's a vector representation of topography. And OpenTopography will make you contours, custom contours on the fly if you're interested. So these are the kinds of data products that OpenTopography is focused on, is these raw data types and then derivatives from them, many of which are produced dynamically by our system. One of the other underpinning kind of motivations for OpenTopography since the beginning was this idea that different users have different needs and different kinds of data types. And so we try to provide a range of different types of data, acknowledging that some users just want a pretty picture they can print out and put on a map board and take out in the field and draw lines on, right? The mapping, faults, landslides, whatever. Other people want really sophisticated programmatic access to raw data so they can build sophisticated processing pipelines. We've tried to sort of serve users across that whole spectrum. So if you want just a pretty picture, you can actually OpenTopo will make it for you and give you back a JPEG or a KMZ file you open in Google Earth, those kinds of things. But if you want to download the 18 terabytes of LiDAR point cloud for New Zealand, you can do that too. Like, buyer beware, it's a much more challenging thing to deal with, but people do this. And then there's a bunch of sort of tools that sit in that middle zone. So like, again, digital elevation models historically have been the most common way to represent topography in a geospatial GIS kind of environment. So there's tools for that. And again, different pathways for different kinds of users, programmatic access, portal-based access. So these are the suite of kind of services that are available. People come to OpenTopography for the data, right? That's the primary driver. So this is a screen cap from the current state of US coverage of the United States. Each polygon, it represents the footprint of a LiDAR point cloud data set. Colored by sort of where the data come from. So red here are data sets where OpenTopography is the primary archive. We host those data sets. Typically, they're more geoscience focused. They're typically funded through agencies like National Science Foundation and other collaborations, groups we've partnered with over the years. Sometimes it's like a state geological survey. Sometimes it's a state geospatial agency, like, for example, Indiana. Everyone's always like, why is Indiana red? Then green and blue on this map are data sets that are managed by the US Geological Survey in green and NOAA in blue. And these are the big players for geospatial data in the United States, taxpayer funded open data sets. And what we do is we federate that data into OpenTopography. So we grab the data from its raw sources, oftentimes now it's in the cloud, and then we dynamically pull it into OpenTopography, and then we put the kind of processing tool stack on top of these data. So the idea here is that you can get this data from the USGS, you can get it from NOAA, you can get it from other places, but we're kind of applying a value add to it by making the data easier by putting these processing tools, visualization tools adjacent to the data. And then the little purple dots on here are data sets that were uploaded by users in our community. So we call this the community data space. It's typically oriented towards academic users who are, say, flew a drone over their field site because they're studying a landslide and they've collected a topographic data and they want to publish that data publicly so that data can be cited in a future publication or in a bit of curriculum or something like that, to comply with kind of open best practices and open data. So we have lots of data from all over the world produced by people from many different countries and different scientific applications, but they tend to be these little kind of postage stamp size site-specific data sets. And so that's what the purple is. So there's 84 trillion points available in mostly LiDAR. Some of them are also derived from photogrammetry available from OpenTopography. So that's a lot of data. But the beauty of OpenTopography is you don't really have to necessarily think about that when you're interacting with it because we basically handle the access and the tile stitching and all the stuff that you would need to do if you tried to just bulk download these data sets and deal with them locally. In addition, there's a whole bunch of global and regional data sets that I will talk about in a second. We have some unique kind of partnerships. We host and distribute all the point cloud data from New Zealand's National LiDAR program. This is a collaboration that's been going on now for quite a few years with LINS. I think that actually is now more than 62 projects, but there's quite a few projects covering 261,600 square kilometers. It's 3.1 trillion points, and New Zealand's getting pretty close to having nearly nationwide LiDAR coverage. All the point cloud data derived from these data sets are available freely through OpenTopography. And so this is a kind of example of us going outside the academic domain to collaborate with other users or other communities to leverage essentially the OpenTopography platform. So we've had over the years groups come to us and say, we've got all this data, but we don't have a way to easily distribute it or make it accessible to our users. Can we just use the OpenTopography platform? And so this is an example of that. So here are the global and regional topographic data sets. So these are, in general, lower resolution data sets. So this is like sort of the data that are like sort of 30 to 90 meter pixel resolution, but are nearly global in coverage. So each of these data sets, whether it's SRTM, which is the one that most people are familiar with, the shuttle radar topography mission, which was collected by a radar on space shuttle, or there's NASA DM, there's ALOS, which is a JAXA product, there's Copernicus, which is a European Space Agency, all these different data products, but they're all digital elevation models. There's not really point clouds associated with these data sets because of the sensor technologies that are used to collect them. And they're, in some cases, truly global in coverage, like pole to pole. In other cases, they're most of the globe, but sort of end at some latitude as a function of the orbital geometry of the sensor or the satellite. So like SRTM on the left, you see has a cutoff that's kind of like a third of the way up Alaska. There's no coverage at the very highest latitudes as a result of where the shuttle was orbiting at the time. Data sets like Copernicus, the Copernicus 30 and 90 meter data sets are truly global coverage. And then there's a set of data sets that the USGS delivers. So this is the USGS, what they call the 3D elevation program now. It used to be called the National Elevation Data Set. You've been around the GIS world for a while. And those are available in 1 meter, 10 meter, and 30 meter resolutions. And the USGS publishes those as standard products, a seamless data set. The US 1 meter data is not quite entirely provides coverage of the lower 48 because that's based on LiDAR data, and the USGS is not quite done covering the US with LiDAR. 10 meter data covers basically CONUS, Alaska territories, and then the 30 meter data is all of North America, inclusive of Mexico and Canada. So you can get all of these products from OpenTopography. We also have some more unique products like Arctic DM and REMA, which is the reference model for Antarctica. These are 2 meter resolution products that cover the Arctic and the Antarctic that were produced through an initiative funded through the National Science Foundation. So this is in many ways like a lot of users of OpenTopography come for this kind of data because there isn't global LiDAR coverage at this point. In some parts of the world, the best available data is, say, a 30 meter DEM. And so if that's what you are interested in, or that's what you can get. And also for some applications, larger scale applications, if you're looking at a whole mountain range, you really don't need to represent it at 1 meter resolution. 30 meter or even 90 meter data is quite sufficient. So different data sets for different applications. And this is an example of just 2 different volcanoes represented in these 30 meter data. So on the left is Fuji from SRTM, and on the right is Mount Etna in Italy and on Sicily. And this is a European digital train model data set, so it just covers Europe. So for certain applications, these data sets are spectacular, and lots of people use them very effectively. So one of the other things, if you've been poking around in OpenTopography, you may have noticed is that certain data sets have a restricted access button next to them. And so I just want to kind of talk about this because this is a relatively new feature of OpenTopography, or a change in how we've operated. So we've introduced over the last couple of years this thing called OpenTopography Plus. And so coming back, just the reminder that OpenTopography is fundamentally funded by the U.S. National Science Foundation in support of earth science research and education. So the National Science Foundation has paid over the last 15 plus years to build this infrastructure, primarily because it helps scientists do various kinds of research, whether that's natural hazards, climate, ecology, etc. And so as OpenTop has gotten grown and the user community has gotten bigger, there's become a little bit of a tension between the number of total users of the system and the amount of resources available to support things like running on-demand geospatial computations on data sets. And because our core customer is the academic community, we've made a little bit of a fork in the way things work. And so if you have an academic email address, a .edu email, you can create an OpenTopography account and you are basically instantaneously get access to all things OpenTopography with no restrictions. If you're an international academic or or you like teach at a K-12 school or something like that, we have an application process, a simple application you can fill out and tell us who you are, how you're going to use the system. In addition, all the global data sets, all the community uploaded data sets, what we call the community data space, all the polygons in red on the map I previously showed you, are all open to everybody. In addition, we have the API that people utilize, and a personal API key is also free to all users. So that allows you to write a little, program to call our API and retrieve, 30-meter SRTM data, for example. But to address this kind of growing community of users, many of whom do not come from sort of academic world, but still appreciate the data and the services provided by OpenTopography, we introduced this thing called OpenTopography Plus. And we did a pilot last summer, and then we rolled it out as a full-on subscription-based program going forward. And so this is you can either sign up annually, or you get 11 months, you get 12 months for the price of 11, or you can sign up monthly. It's a pretty simple process. You click, put your credit card in, so get access. And you can cancel at any time if you're on the monthly program. And the idea here is that this is really targeted at kind of commercial sector users of the system who are routinely using and consuming resources and trying to kind of build a sustainability model on top of OpenTopography that is not exclusively reliant on the National Science Foundation and having the National Science Foundation subsidize commercial applications. We've been fortunate to have a really strong sponsor in the National Science Foundation for 15 years, but our budgets are pretty modest. And so the idea here is that the OT Plus members sort of are acknowledging that they appreciate the service that is provided and the investment NSF has made, and they help to offset some of the costs associated with running these services, hosting data, answering user emails. These are all things that take time and money. So if you see this is what this is about, and we're happy to answer other questions about this, but we just wanted to clarify this early and up front because it is a relatively new change if you've been using OpenTopography for quite a while. And I guess I should just be explicit here that the OT Plus does not apply to all data. It's just applying to these sort of REDEP and NOAA coastal LiDAR, as well as the two kind of polar data sets that are available in OpenTopography. So now to talk a little bit more about the functionality of OpenTopography. So there's a whole bunch of, we basically provide access to these raw data sets, 84 trillion LiDAR points. But then on top of those data sets sit a bunch of processing tools that do different things. So that could be, I want to make a custom digital elevation model for an area of interest. I want the data to be at 0.5 meter resolution. So I draw a box on a map and we do the rest. Derivatives of those topographic data sets, such as hillshades and slope maps and other things. We will compute the height of the trees, which is called a canopy height model. Contour lines, there's a tool for visualizing the point cloud data in the browser. We have some more sophisticated tools related to topographic change, so intercomparison of overlapping data sets. So this is what we'll be focused on in the 4th webinar in this series. So come back in a couple of weeks if you're really interested in this topic. And then there's some tools for hydrologic routing. So basically flowing water over the landscape and watching where it goes. And these are more powerful, more sophisticated tools that are available to certain users. Um, so just a couple like kind of just hits of these things just to show you, and we'll talk more about these tools in future webinars in the next week and the week after when we talk about how to run a full job and process data and the nuances of different processing selections. And Matt will lead that and we'll do kind of a demo. But this is the point cloud viewer. This is looking at the state capitol in Salt Lake, Utah, and just showing kind of how you can toggle between different attributes of data and look at these things interactively. This is in the browser. You don't have to download anything. It just fires up in your WebGL enabled browser, and you can look at data sets and kind of do cool things like make profiles across the data um, and other sorts of applications. So this is just a little video for showing that. Um, Visualization, these are raster-based visualizations, so hillshades, polarized hillshades, slopes. These are very common geospatial uh, tools that people who work in ArcGIS or whatever make these all the time when they're pulling a digital elevation model, and we just do it for you. So if you don't want to have to bother running your Arc toolbox to produce these things, you can just select them as an option in OpenTopo, and you'll get them back as part of the process. Here's a Google Earth. This is a digital elevation model, polarized, hill shaded, and exported as a KMZ file. So if you're somebody who likes to use Google Earth as your basic sort of visualization platform, it's really easy to go from a selection in OpenTopography to a KMZ file you can look at in OpenTopography. This one's overlaid on this is Crater Lake in Oregon. Topographic differencing. This is the intercomparison of data sets. Again, we'll do a whole webinar on this in a couple of weeks. So this is a little bit of just a tease to get you to come to that one. This is an example of comparing two overlapping LiDAR data sets at White Sands National Monument in southern New Mexico. These sand dunes are super dynamic and moving very quickly. So you can actually take two time steps of data, compare them, and you can see how much the dune had migrated. In this case, the dunes go from southwest to northeast. And the color is blue is accumulation of new sand, so the wind's driving the sand to the northeast, and red is sort of the scouring removal of sand. So it's the dune field marching northeast. We also have tools to do this for things like earthquakes and landslides intercomparison as well. So this is a newer set of functionality, but it's quite cool because we're getting to the point, at least in the United States, where we have multiple LiDAR collects in many places. And so instead of being a single time stamp of the landscape, we can actually look at change in the landscape. And so this has been an emphasis of OpenTopography over the last several years, is building tools to enable that kind of interactivity. Hydrologic routing is, again, another more sophisticated workflow that is quite compute intensive. So this hydrologic terrain analysis products output uses an open source toolkit called TAUDEM. And we did a bunch of work over several years ago now to kind of optimize this and get it running on true high performance computing infrastructure. So this runs on an HPC machine at San Diego Supercomputer Center, and it does a suite of steps to basically route water over topography. And you can choose which parameterization you want. I'm not going to go into how hydrologic routing works in the interest of time, but if you're somebody who uses this as a tool, you can use OpenTopography to do it for you and to generate things like topographic wetness indexes and contributing areas and hydrologically corrected pit-filled digital elevation models and those kinds of things. And when you get the products back, you can make visualizations such as contributing area and flow direction, basically which way is the water flowing on the landscape and where does it end up in the landscape. So basically, where are the creek bottoms, so to speak. So these are more sophisticated tools in OpenTopography, but they are available to users. So now I'm going to throw to Matt, who's going to do a little demo of OpenTopography, just sort of cruise around, show you how to use the basic data discovery and access tools. I'm not going to run any jobs. And then we'll come back and finish with a few more slides before we go to questions. Matt, take it away. I'll stop sharing.
Yep. Okay. I assume you can see my screen, but just let me know if you can't. So I'm gonna just talk about data discovery, how to find the data basically through Open Topography. And I'm gonna start off with how not to find data. We've had some users that have typed in a lat long to this search Open Topography toolbar up here, and that's not how you search for data. That is to search our website and web pages. So if you're looking for a blog post or a news item or anything like that, that's where you'd search for data. I'm sorry, that's where you'd search for web content. If you want to search for data, there are two primary avenues. There is, if you go to this data menu item and drop down, you'll see find data map and data catalog. Those are your two primary pathways to access or discover and access data. So we'll go through the find data map first because that's the primary one, and then I'll talk about the data catalog after that. So this is our find data map. It's a basic web map. Most people are probably familiar with this. You have, your basic options. You can change your base map. You can use the hill shade. This is a hill shade from the USGS web mapping services of all the US. You have, your basic satellite imagery with vector town names and state boundaries and other things on that. So that's useful sometimes, especially if you're looking for a certain feature. On the right, you have a listing of all of the spatial extents of the data sets that we have. Chris went through some of these, but just to reiterate, these red polygons are data sets that are actually hosted at OpenTopography, and this is free and open to everybody. So everyone has access to these data sets. You can see it's primarily focused in the West Coast, but we do have the whole state of Indiana. We had a partnership with them. And then if you go to New Zealand, you see we have most of New Zealand covered as well. If you ever want to reset the map, there's this little reset map button here. You can reset the map. Obviously, the map is sort of dominated by the USGS 3DEP as they're mapping the entire US. You can see these little lock icons. That just indicates that those are the two data sets that Chris mentioned that are currently restricted. They're open to all academics, anyone with a .edu address. Otherwise, you can either apply for access if you're an international academic, or you have the option of using OT Plus to get access to that data. Blue polygons are NOAA Digital Coast. This is mostly coastal data, but they're also inland waterways. Community data space. They come up as little polygons. They tend to be smaller data sets, but if you zoom in, you'll see that you'll see the spatial extent of these polygons. In this case, this was drone surveys over a cliff near Lake Michigan. So for the community data sets, since they're small, they just might come up as dots. And then finally, the global and regional data sets. Since we have a bunch of them, there's a little drop down, and you can just select the data set you're interested in, and it'll show you the spatial bounds of that data set. And speaking of spatial bounds, if you ever wanted to pull these boundaries into your own GIS, there's this button here on the left at the bottom there, and it's download this data set. So this way you can pull in these boundaries into your own GIS if that's useful to you. So I'm just going to reset the map. One little minor feature that's new that even people that use OpenTopo might not know about is we added a little locator button. It's this pin over here. And it has a gazetteer and also has a section where you can enter a lat long bounds or just a lat long point, and it'll zoom to that area and show you what data sets are available just for that region. So here we're just looking at the city of Seattle. So this top one uses a gazetteer and it zoomed to city of Seattle and shows you all of the intersecting boundaries of that area of interest below the map. And this is another sort of section of OpenTopo where we've done some reorg recently, so I'm just going to walk through this a little bit. But before I do that, let's go back to another method. So that's the one method of using this point by location. Let's reset the map. The primary way people are going to use this map is by just drawing their own area of interest. So let's say you would just click this select a region button. and just draw your area of interest. So here we selected Southern California, and these are all the intersecting data sets for that region of interest. So we've grouped all the data sets into sort of three primary tabs. There's the global and regional DEMs. These are those data sets in orange that we saw before. These are those gridded data sets. A lot of them are satellite based. They tend to be a little bit coarser resolution, but they have global coverage in some cases. The USGS 3-depth rasters are actually one of the finer resolutions. They come in 30 meter, 10 meter, and 1 meter resolution. The next tab in the list is what we call high resolution topography. These are our high resolution LiDAR data sets. So this has three submenus, which might be a little confusing, but the breakout was sort of by design. We have the OpenTopography data sets. These are those polygons in red. These are data sets that are hosted at OpenTopography and are open to the entire community. We have the middle tab is the USGS 3-depth data sets. And then the right-hand tab is the NOAA Digital Coast LiDAR. And one thing I wanted to point out for this is we've added, you can see these little open data tags and academic access and OT plus tags. This was to sort of alleviate that confusion that people had, is the data open or not? And you can see that for the open topography hosted data, it's all open. For 3-depth data and for the restricted data sets, some of it is open, and that's because what we've done recently and we will continue to do in the future is that any kind of natural disaster that happens, like in the past, there was some flooding in Vermont, there was a hurricane in Florida, and then most recently there were these fires in Southern California. So anytime there's an event like that, we make all of that data open, even if it's 3-depth or NOAA, with the hope that it would help with disaster response or any kind of emergency response. And so anyone can access those data. It'll be open for a limited time. And so all of these, because we selected an area in Southern California, all these data sets that intersected that are open, whether it's 3-depth, NOAA, or whatever. And then finally, we have a listing of the community contributed data. These are those small points in the purple points in the map. These are users who upload data to our servers and share it with the community. These are always open to the entire community as well. One last thing with the find data map is we're starting to get in a very data-rich atmosphere, and so we're having more and more data sets, and so which is a good thing, but sometimes on the map it can be very cluttered. So if there's ever a data set that you're interested in, like let's say you wanted to see this Eaton Fire data set, there's this little pin to the right, and if you click on that, it will isolate just that data set. So you can see the spatial bounds of just the data set you're interested in, just to remove it from the noise of all the other data sets that might be on the map. So that is the find data map in a nutshell. The other avenue that I mentioned is you can click on the data catalog. So the data catalog looks much like that subset of data that you were seeing under the find data map, except this is everything. This is the entire data sets that OT hosts or has access to. So this is useful if you just wanted to browse, or if you knew the actual name of the data set that you're interested in, you can just jump directly to that. It has the same breakdown in groupings, global and regional DEMs, high resolution LiDAR, and community contributed. One thing to point out here is you have all these filters, which you also have the option in the find data map. So you can filter by grouping. Let's say you wanted to see open topography hosted data because it's open to everybody. So you can see we have 486 data sets that you can access. You could filter by location. You could say, just show me data sets in California. You could also do some kind of advanced filtering where, let's say you wanted to search for just bathymetric data, or you wanted to see all raster data sets that have orthophotos. So you can click on that, and it'll show you we have 30 hosted data that have orthophotos included. So just another way of sort of fine-tuning your search. You can always just dump in a keyword as well to search if you're looking for a specific feature. Just another nice way to sort of fine tune your data search. Um, One thing I'm just going to reset. So we're back at full listing. One thing to mention here that sometimes can also confuse people that I just want to clarify is these different buttons. So you'll see there's a differencing button, get point cloud data, get raster data. So when data collectors or data providers give us the data, we generally don't do a lot of post-processing or create extra core products. We do derivative products from the data, but we don't always get a full suite of data from the providers. Sometimes we just get the LiDAR point clouds. Sometimes we just get a raster or gridded product, and sometimes we get both, in which case the collectors provided LiDAR point cloud data, and they also created a gridded raster product that they want to share with us. So, for example, this Alaska data set you see, we have both point cloud and pre-computed raster data for that data set. So that's just one distinction. We'll go a little bit deeper in the next couple webinars about how to grid data from point clouds versus the pre-computed and what the differences are. But just be aware that that's what those buttons are and why not every data set has both buttons. The differencing button is a result of us having more and more data sets. And so we're getting data sets that overlap. And so now we're getting to the point where we could start doing differencing operations. And as Chris mentioned, Chelsea and Cassie will dedicate a whole webinar at the last webinar of the series to differencing and how to work with the differencing tool. So that is sort of searching for data discovery. The one last thing I want to point out that people might not be aware of is if we go back to the find data map, sometimes we might not have a data set for an area that you're interested in. And so one really useful tool that we've made available is this USIEI. It stands for the US Interagency Elevation Inventory. It's a really nice sort of metadata geo package that's created and maintained by NOAA, and they do a really nice job. The idea was to be able to just discover what LiDAR data and high resolution data is available in the US. You can see it's dominated once again by the 3DEP, but it wasn't always this way, and sometimes it was hard to find what data is available. So if you can't find the data that you're looking for, or we don't have it at OpenTopography, you can use this tool just to see what's available spatially on the map. So you can go to your area of interest and you can click on one of these polygons, and it'll pull up the metadata that's in that geo package and very often show you links to get the data, not all the time. And we don't maintain this geo package. This is maintained by NOAA. So, but very often it'll be links to the data sets, or at least links to some of the critical metadata pieces so that you can track down that data and then access it yourself. So just another sort of data discovery tool that users should be aware of. Next week, we're going to sort of do a deeper dive into point clouds and sort of running a point cloud job, some of the metadata pieces. We'll talk about the 3D visualization, and we'll also talk about like bulk downloads, how to like bulk download data sets and not go through the GUI. So that'll be next week. If you're interested in that, come back for that piece. And I think that's all I had, Chris. So I'm going to stop sharing and pass it back to you.
Cool. Thanks, Matt. Yeah, we'll jump back over here. That USII that Matt was talking about is kind of interesting because sometimes these kinds of LiDAR data sets get collected by like state and county and local governments, and therefore don't have the backing infrastructure necessarily to have them published as part of like a USGS 3DEP or even on OpenTopography. So sometimes even you click on one of those data sets, you'll see that it's like you got to call Geo at the county GIS office because he's got the data on a hard drive. And if you know who to talk to, you can actually get a copy of that data. That's where USIEI is nice. It fills the gap for these like smaller kind of locally funded data sets. So it's an inventory that sort of makes you aware of data sets that may not be part of these larger geospatial collections managed by the big agencies. All right, so let's go back to a couple more slides just to wrap up, and then we can take a couple more questions. So just a little bit more about kind of the broader context of open topography. Um, there's 260,000 registered users of open topography. Um, this the site has grown dramatically, and so this is in part why this whole Open Topo Plus thing was put in place. Is that there's a significant number of users of the system that are international, that are coming from non NSF supported communities, and so when we're thinking about how what we're building in Open Topography, we're trying to address the core user community, but also people in industry and international and government and all these different potential users. And some of these things, like our APIs, get pounded 5.3 million API calls to request topographic data over the last, can't remember exactly how long that's been, but it's like 5+ years. Um, for us, one of the primary motivations is facilitation of research. So since 2009, since Open Topography began, the OT's enabled 1,204 peer-reviewed scientific publications in lots of different disciplines. Earth science kind of dominates here in orange, but also other sectors, including computer science, cyber infrastructure, remote sensing, geospatial analyses, ecology, et cetera. And so this is like when we go to the National Science Foundation to request support to continue running Open Topography as a free resource. This is a big part of the sales pitch is this piece. But we also know, as I said, that lots of people are using Open Topography for other purposes. Um, People pulling data from OpenTopo to use in video games, kind of virtual world development, whether that's World Machine or Minecraft or Unreal Engine or all these other different platforms for kind of virtual data visualizations. 3D printing is a large market for us. A lot of people pulling data for making a 3D print, whether it's their favorite rock climbing location or some other kind of cool application of 3D printed topography. And then lots of commercial sector consulting and agency activity and agriculture and all these kinds of things. So um, it's kind of an interesting thing that's happened with open topography, and I think it really just speaks to the power of these kinds of high resolution topographic data sets, that they're broadly applicable as sort of framework geospatial data sets for all kinds of things. So just to wrap up with a couple of just reminders of other resources, because we're not going to go into these in much detail in the future webinars, but we have a lot of training resources. We do a lot of in-person short courses, less so, and we do more webinar virtual things now in the post-COVID world, like many people. But we still do hands-on in-person activities at typically co-located with other meetings, like say the Geological Society of America meeting. We have developed a lot of different tutorials, both on how to use open topography. So if you just want to watch somebody kind of walk through and run a job, you can find tutorial videos on our website. Or specific, like there's a great tutorial on how to run the hydrologic tools, TAUDEM. And then also curriculum development. So if you're an educator, I'm not sure how many people on the total number of attendees here are using these kinds of data in a classroom, but we have pre-existing evaluated teaching resources that can be brought into sort of undergraduate to graduate level classes, and we're doing more work on that area to try to build out additional teaching resources. So just to make you aware of this, if you go to the Open Topography webpage, there's a education training kind of resources tab that will take you to a lot of this stuff. And I will say, if you're looking for something in particular, you can't find it, you're like, I wish there was a tutorial on how to do this, send us an email, where info@opentopography.org is our general email address, and one of us will respond to you and try to point you in the right direction, because there's a lot of content out there. Sometimes a little tricky to navigate if you're not familiar with it. Kind of open source code. We've got a lot of different Jupyter notebooks and open source code that we developed over the years. These are obviously oriented towards more sophisticated kind of coding development type of users, but there's a lot of really great resources that have been developed over the years. For example, this tool that was built by an intern that worked with Matt and I a couple summers ago, Kenny LaRue, PhD student at University of California, Davis, wrote this amazing tool to kind of automate the generation of these relative elevation models, which we'll talk more about relative elevation models in a future short course. But this is a really cool package that produces really pretty visualizations, and it's oriented towards sort of hydrologic landscapes, fluvial landscapes, and makes like the picture here is an output of this thing. And so this has been a really cool kind of example of the kinds of open source code that we've been producing. Um, Another thing that people, as I said, are really excited about is 3D printing, especially now that 3D printers have become very affordable. We have a really nice tutorial that Emily Zawacki developed on how to go from a digital innovation model downloaded from OpenTopography into a fully 3D printed model, including some discussion of different materials and different online printing sources. Even if you don't have a printer, you can actually upload these things to a service online for tens of dollars. They will send you a 3D printed piece of topography. Uh, so there's a lot of cool resources out there that just want people to be aware of. So that's basically wrapping up the kind of this intro to open topography, kind of a quick pass through a bunch of different things about open topography. Um, you know, the kind of take homes here, I think, are that, we believe open topography is the most comprehensive source of topographic data on the internet. It's not the only source, for sure, and it's not all the data. We're working on trying to expand, for example, our global footprint for, say, high resolution data sets in other parts of the world. But if you're looking for data, we're a great place to start. There's a lot of education training resources if you want to sort of self-educate. Uh, and then I think, there's a lot of really exciting things happening with these large-scale nationally led initiatives to map whole countries, whether that's New Zealand, whether it's the United States 3D elevation program. Similar initiatives are happening all across Europe. Uh, Having this kind of data, when I started doing this kind of work, working with this kind of data, it was very rare to have these data sets, and people got very excited. But now it's in some places there's nearly wall-to-wall coverage, and creates a lot of interesting opportunities for large-scale data analysis. And if you have overlapping data sets, intercomparison. So again, another carrot to come for the fourth webinar when we talk about topographic differencing, because there's a lot of really cool things you can do when you start having multiple data sets in one place. So that's the kind of conclusions. I just want to remind everybody once again that this is the first of 4 webinars. Come back next Wednesday at the same time, same place, using the same Zoom invite link. And we will talk about point cloud processing, how laser scanners work, a bunch of cool stuff in that presentation next week. So thank you all for coming. We're happy to answer any additional questions. Toss them in the Q&A, and we can also go through, and I'll go through and look at some of the answered questions and see if there's anything that we want to dwell on. As always, we're happy to answer emails from our users. So if you have a question, you're looking for something, you're confused about something, shoot us an email at info@opentopography.org, and one of us will get back to you. Probably Matt or I do most of the email answering at OpenTopography. And then also, we're on most of the social media platforms under @OpenTopography or some variant. So if that's how you prefer to get information, check that out. Follow us on Instagram, follow us on Blue Sky, LinkedIn, Facebook, all those places. And then the last comment was also just that we do have a newsletter that we send roughly once a month with kind of updates about things that are going on, new data sets, upcoming webinars, short courses, other interesting things. So when you create an Open Topography account, you can subscribe to the newsletter as well. So that's if you just want kind of a little bit of an update about what's going on with Open Topo. That's another great way to get that information. So any questions that we want to answer, toss them in the Q&A. Anything, Matt, you want to say since you've been answering questions and I've not been paying close attention?
No, just lots of good questions. Thanks, guys, for asking them. And it's good to clarify a lot of questions about, OT plus and what's available to .edu users, non.edu users.
Yeah, I see a couple questions about other kinds of resources. So yeah, everything on GitHub, everything on the education training resources, YouTube, all that stuff is free, and please share and utilize. The only thing that has a restriction are these specific subset of data sets that, and it again only applies to non-academic users at this time.
Yeah, and I'll talk a little bit more about that in the next couple of weeks. I mean, part of that is because we don't actually host the 3DEP and NOAA data. We're actually dynamically accessing it. So it's a little more resource intensive than if it was something we hosted locally, but that, as most people can imagine, that 3D data collection is enormous. Latest check was almost half a petabyte for that, just the 3D LiDAR. So it would be quite a large amount of data to host. So that was part of the reason of sort of um, having to go to this pay model.
There's a question: is it possible that 2 to 3 years ago, OT featured more regional data sets outside the No, we've only gone in the direction of more data, not less. So it may just be how you were discovering the data. The user interface has changed over the years. Um, uh, so if you're looking for data, say over Europe, Japan, those kinds of places, with a few exceptions, your best bet is the regional and global data set section of OpenTopography, where you'll find 14 or more different data sets, but they're covering those areas, but they all tend to be at that sort of 30-meter resolution or lower. One of the things we're working on is trying to provide access to high resolution data in other parts of the world. Because as I said, there are significant initiatives in places like Europe to publish sort of USGS 3DEP style data sets across whole countries, or similar to the New Zealand initiative as well. So we're working on it, but we don't have it's a little bit complicated, as you can imagine, trying to sort of dynamically reach into all these different repositories and pipe them into a single unified interface. So it's a work in progress.
It's been a big request by a lot of people, and yeah, we'd like to get there. I could ask the next, Shane, your question is really good about map projections. And it would be something that we would like to do. It's been on our list to be able to output in a lot of different map projections. It's kind of a mixed answer. So for the stuff that we host, we just return it in the projection that it was provided to us, if it was UTM or whatever. So there's no way of reprojecting. For the 3DEP and the NOAA, we do allow that. So the 3DEP in particular is in a Web Mercator native projection. You have the ability to reproject into two flavors of UTM, either NAD83 or WGS84 based, or geographic coordinates like lat lon. So at least with the 3DEP and NOAA, you have some other options, but the bulk of the data, if you're running a portal job, it's going to be returned in whatever the native projection was that it was provided in.
Yeah, and I'll just follow that up to just say that reprojection gets really, really, really complicated really quickly on these data sets, especially because the underpinning metadata describes the sort of nuances of the coordinate system sometimes are not as well documented as we might like. And so sometimes getting the transformations correct gets messy. We've spent a fair amount of time worrying about this. I'm sure Chelsea and Cassie will talk about this when we get to the topographic differencing exercise, because making sure data sets are on the same coordinate system before you compare them to each other is really important. So, Matt, do you want to
Yeah.
answer Juan's question
Yeah, I
about
was gonna say
mean sea
one.
level?
Yeah, most of it's not mean sea level. Most of them are. It's a mix, and so that's where, like Chris says, we get married. It gets messy. A lot of them are ellipsoidal based, so they don't have a geode applied, which means they're not an orthometric height. But not all of them are. Some of them have a geode applied, and then there's multiple flavors of geoid. You have, geoid 12 is a common one, but more of the recent like 3DEP data is with respect to geoid 18. There's older versions of geoids. Some of the global data sets are with the Earth gravity model, EGM 96, EGM 2008. So we make sure that we do our best diligence to sort of document what the vertical datum is in the landing pages, and we'll talk about that next week. So yeah, it's not a uniform all data sets relative to mean sea level. It varies.
Yeah, unfortunately, the devil's in the details when we start getting into issues like this. So again, if you're struggling with something and you really want help, like shoot us an email. We'll do our best to either answer a question um, about the data sets or point you maybe to other resources that we are aware of. Um, the other thing Matt will talk about next week is like data set landing pages. So we've spent a lot of time trying to document the best of our ability, at least, what coordinate systems and vertical datums and things like that are applied to data sets. And so Matt will show you when we talk about how to access data, access and process data, how to interpret sort of that information, how to get that metadata. Because if you're doing more sophisticated kinds of things, you definitely want to sweat the details there. Let's see, Chelsea answered Santiago's question. Um, so she said, yeah, you can apply for access, but I think the other piece of the question that Santiago is asking is OT database is restrained to US only. Um, and I think the comment there is that, there's good, again, these global data sets, the like 30-meter resolution data sets, there's plenty of options over South America. The complexity is that in a lot of parts of the world, there just isn't high resolution LiDAR data, period. Or if it's been collected by industry and it's not open, or it's been collected by a government agency that does not have an open data policy. Um, so uh, we get this email a lot, which is like, I'm in this country in Africa and I want 1 meter LiDAR. And the answer is oftentimes, I'm sorry, like it either doesn't exist, or if it does exist, you've got to like do some footwork locally and you got to start calling government agencies, companies to see if anybody's collected it. The US and increasingly Europe have a quite progressive open data stance when it comes to these kinds of geospatial data historically. Um, and so we're fortunate that these data sets are paid for by tax dollars and made open with very permissible licenses, but that's not always the case. And so this is one of the reasons we'd like to start pulling in more data from other parts of the world, just so people can see what does exist publicly. But in a lot of parts of the world, there just isn't this data. And so that's where you need to look at these data sets that Chelsea just linked to. Or kind of roll your own. If it's a small site, a drone with a camera can do quite impressive things to collect topographic data with a photogrammetric workflow. We'll talk a little bit about photogrammetry next week, but not in great detail. But we can point you to some tutorials and resources on how to basically make your own topography with a cheap drone and a camera.
And Chris, there was a question about access to the 3DEP data and so forth from .gov emails.
Yeah. So at the moment, .govs fall on the OT plus side of the equation, which is not something we love, honestly. We'd like to kind of make our government science colleagues able to access the same data that the academic community does. But at the moment, we've started with a relatively aggressive posture. We've made some forays to the US Geological Survey to see if they'd be willing to collaborate with us on this. And we've had a little bit of luck at the kind of programmatic level. We've gotten some funding from the USGS to support specific groups within the USGS having access to data through OpenTopography. But at the moment, we're not quite there yet. So, if this is something we're evaluating, we're watching to see what the subscriber interactivity is and things like that. But if you're interested in this and you represent a government agency, shoot us an email. We'd love to talk honestly about ways to do this. It's not a position we're just trying to cover the costs associated with running this infrastructure and trying to make the thing sustainable such that if we receive future funding cuts, which paying attention to US news is quite a possibility. We've got a hedge essentially to keep OpenTopography running. We're trying to figure out how to build a sustainable ecosystem. Other questions? Oh, somebody asked if you could go ahead, Chelsea.
There's been a couple of questions that I've answered where people have asked if you can use basically OT resources to run data that is on your computer and essentially not on OpenTopography. And the answer is no, you can only run jobs on the browser with OpenTopography's data. But we do have our GitHub resources that have codes for conducting many of the analyses. And so you can implement and get those codes running on your computer and apply them to your own data.
Yeah, and thanks for saying, because I did see that's been asked more than once. So the other comments are, OpenTopography is built on an open source stack of technologies largely. So if you want to create some more processing pipelines and you've got data you can't, that is proprietary or local or whatever, you can do so using a suite of kind of the open geospatial software stack, tools like GDAL and PDAL and Proj and OGR and all the kind of class. These are all this is what underpins the open source geospatial stack. That's what's under the hood in OpenTopography. And so, as Chelsea said, there are resources. You could also email us. The other comment is if you have a data set that is interesting, especially interesting from a scientific use case perspective, send us an email because we can talk about how to get it published in OpenTopography. We work with all kinds of different groups to make data available. And so if you have a data set you'd like to share, please let us know and we can talk about how to get it published. Okay, we're past the hour, about 66 minutes. So thank you all for coming. Again, next Wednesday, same place, same time, same Zoom link. And we will talk about point clouds and point cloud processing. Thanks, everybody.